Esteemed colleagues, this presentation elucidates a structured approach for setting goals in the development of cyber-resilient systems. This approach is formulated in accordance with the guidelines and recommendations provided by the United States National Institute of Standards and Technology. The primary objective of this paper is to offer both researchers and practitioners specializing in cyber resilience comprehensive roadmap. This roadmap aims to guide the development of information systems that can not only withstand but also adapt to various adverse conditions, disruptions, and cyber attacks, while ensuring the integrity and continued operation of core system functionalities. The exigency for resilient systems in contemporary times is escalating at an unprecedented rate, catalyzed by a mutable threat ecosystem, burgeoning political, social, and environmental volatilities, pervasive digital globalization, and an intensifying societal reliance on technological infrastructures for essential services. Traditional cybersecurity paradigms are increasingly ineffectual in engendering resilience under these circumstances. Acknowledging the technological limitations inherent in ensuring absolute security of information assets, the United States National Institute of Standards and Technology has promulgated a succession of special publications, elucidating the tenets of resilience. These publications advocate a concept aimed at bolstering system reliability through the instatement of adaptive mechanisms, proficient in mitigating the ramifications of disruptive incidents, malevolent incursions, or endogenous system failures. The resilience model places an emphasis on the perpetuation of mission-critical processes, and expedites the efficacious restoration of systems post-incidents. The locus of this research is pivoted on the procedural aspects of delineating goals for the construct of resilient systems, and the evaluative metrics to quantify their attainment. Goals are high-level articulations of desired outcomes that are common to many definitions of resilience. They are included in the Cyber Resilience Building Framework to provide a link between risk management decisions at the system level, mission level, and business process level, as well as at the organizational level. Organizational risk management strategies can use cyber resilience goals and associated strategies for cyber resilience integration. It is imperative to clarify that cyber resilience goals do not serve as terminal objectives, rather, they function as contemporaneous strategic imperatives that sculpt the operational schema of an organization. They are the cornerstone of the NIST Cyber Resilience Building System and are vital for developing a comprehensive cyber resilience strategy. These goals guide risk management decisions at various levels: systems, missions, business processes, and the organization. They provide a more unified approach to risk management, bridging gaps between different organizational levels and promoting a culture of proactive cyber resilience. In line with the definition of cyber resilience, it is important to understand that desired outcomes go beyond simply preparing for and responding to cyber threats. They also include the ability to evolve and adapt under the influence of these threats, thereby improving the overall cyber capabilities of the relevant organization. Cyber resilience is not a static quality but a dynamic one that requires continuous development and improvement. To understand the essence of cyber resilience and how it differs from cybersecurity, it is necessary to consider each of the goals described in the framework. Anticipate. This goal focuses on proactive measures to predict and identify which system elements are most important for the organization's operations, and are vulnerable to sophisticated professional attacks, unpredictable failures, or incidents. All risks with a critical level of harm, regardless of the likelihood of their realization, must be considered and processed by applying resilient solutions to them, assuming that the threat, however unlikely and complex in realization it may be, will still be realized. Threat intelligence, risk assessment, and predictive analytics play a key role in achieving this goal. It is not enough to simply respond to threats, organizations must anticipate them, implementing resilience elements in the most critical and weak elements of the organization's operational system. NIST advocates a proactive, anticipatory stance on threats. This involves conducting comprehensive operations to scout for new types of threats, to identify potential attack vectors, and predict new threats. It also includes regular audits and stress testing of systems to detect vulnerabilities before they can be exploited. Such forward thinking should permeate all levels of the organization, encouraging vigilance and continuous learning. This goal also involves developing a culture of awareness, education, and constant vigilance. Withstand. The Cyber Resilience Framework helps to create an additional protective contour for the organization that is activated when cybersecurity elements cannot cope with an attack, failure, or adverse event. The practical realization of this goal means that resilient systems should be capable of withstanding adversity, guaranteeing minimal necessary functionality, for example, satisfying critical mission needs. New cyber threats can be tested on a range, or in an isolated environment, with the aim of determining the system's ability to withstand them. Understanding the limitations of individual entities, organizations, and systems is crucial. Resilience should also be achieved through protective measures to prevent cyber threats from becoming real attacks. These measures could include implementing multi-tiered defense strategies, developing secure software and systems, using reliable encryption, and maintaining proper cyber hygiene. However, this also extends to the human elements of cyber resilience. Employees must be trained to recognize and resist social engineering attacks, for example. The aim here is to strengthen the organization's defense using methods that do not fall within the information security framework. Recover. The ability to quickly restore normal operation after a cyber incident is crucial for cyber resilience. Swift and effective recovery can significantly mitigate the impact of the incident on the organization's operations, performance, and reputation. Recovery is a multifaceted process. It involves not only the technical aspects of restoring systems and data after an incident, but also managing the broader consequences of a cyber attack. This could include communication strategies for managing reputational damage or legal considerations in the event of a data breach. In line with the resilience concept, systems should not only withstand and recover from blows, but also undergo iterations, as a result of which they will become even more reliable. Systems must adapt to new types of threats. Adapt. Perhaps the most important aspect of cyber resilience is the ability to continuously accumulate information about incidents, vulnerabilities, new technologies, and adversaries, and accordingly adapt strategies. This can include reviewing security policies, enhancing threat intelligence, and reassessing risk management strategies, which should occur with a certain regularity. During an attack, a resilient system must be able to quickly adapt, find new resources, and adjust, even with reduced functionality, to perform its primary tasks and minimize damage from potential threats and attacks. Continuous learning and system evolution are keys to maintaining resilience in a constantly changing cyber threat landscape. It is precisely this adaptability, combined with a reliable approach to anticipating, withstanding, and recovering from cyber threats, that defines a truly resilient organization. The goals are not linear stages that need to be executed one after another, but rather intersect and are interdependent aspects of cyber resilience. A key feature of the resilience concept is the assumption that all four goals must be addressed simultaneously. For example, even while withstanding a cyber attack or recovering from it, mission or organization management structures should anticipate other attacks. Even when predicting, withstanding attacks, or recovering from them, mission and business segments, as well as mission or business processes that rely on them, continuously evolve to meet the changing operational and technical environment. At all levels of the framework, the approach to cyber resilience has a cyclical and continuous nature. Regardless of the stage the organization is at, predicting future threats, resisting attacks, recovering from incidents, and adapting strategies must be constant processes. Defining and agreeing on cyber resilience goals is a collaborative work involving various stakeholders in the organization. The risk management function can be assigned to a group, which typically includes senior-level managers. They must first have full information about the organization's priority goals, and the critical processes without which the organization cannot operate at a level sufficient to achieve these goals. Secondly, they must have the authority to make decisions based on risk assessments that affect the organization as a whole. All managerial roles in the organization should cooperate to perform tasks related to risk management. This includes setting and agreeing on cyber resilience goals. These goals should reflect the results of risk assessment and should be supplemented with tasks in such a way as to ensure resilience, primarily, of the most critical systems, operations, and data of the organization. In light of the fact that goals constitute high-level constructs of the cyber resilience framework, the metrics that evaluate the level of their achievement must hold constructively significant value for making strategic decisions at the higher echelons of organizational hierarchy. Concurrently, to ensure comprehensive understanding and acceptance of these metrics, the results must be presented in a manner that makes them accessible and comprehensible to individuals lacking specialized knowledge at all levels of the organization. Taking into account these multivariate considerations, and acknowledging the paucity of rigorously defined evaluative metrics within the NIST guidelines for assessing high-level resilience goals, we advocate for the implementation of a longitudinal analytical methodology. This approach is designed to chronicle the dynamism inherent in the progression of resilience, utilizing a set of proposed metrics elucidated comprehensively within the corpus of our manuscript. We extend our gratitude for your attention, and cordially invite you to peruse our article for a more in-depth understanding of the aforementioned metrics. Thank you.
Thank you. So, dear colleagues, if you have questions, you may send it to us by emails.
Yes, we can just discuss about topic of this presentation. The topic is really very interesting.
Yes,
because
it's very important and very interesting. The security is the highest level of our life.
In this case, we have aspect resilience in cybersecurity, because resilience is a very interesting concept, and there are a lot of different understanding. What does it mean, resilience? We understand resilience in point of view safety, for example, and in this case we talk about 3 points. If you talk about resilience, first one is attributes which describe possibility of system to continue your work when requirements to system are changing. And so it is aspect self-evolution of system, changing of requirements, and system continue your work. Second one, if we talk about changing of physical or information environments, parameters, the changing of parameters of environments, and in this case, system self-adapting and can go ahead, take into account changing of such circumstance. And third one is the unspecified failures. Unspecified failures and the possibility of system to tolerate such unspecified failures.